Yay!
Yay! Hey everyone, I just wanted to do a really quick problem on how physicists think about factors and scaling problems. So this is going to be really, it is probably really easy, but I just wanted to, because we're going to be doing this a lot, I just wanted to show you an example. Remember, we said that the work done is just equal to the change of the kinetic energy, right? So what I have drawn is maybe these are like rifle barrels, gun barrels. I'm not sure if that's actually 4 times the length, but we'll say it is. So if I have one gun barrel that's length L and another one that's length 4L, what I want to know is how does that affect the speed of the bullet coming out? Speed of bullet. Okay. And here's what we're going to assume. Inside the barrel, we're going to assume, I mean, what makes the bullet go anyway? It's just the expanding gases behind the bullet. Give it a push. So if it's in the barrel for a longer distance, there's more opportunity for the force to act, right? So here's what we're assuming. We're assuming that if the barrel is 4 times longer, then the work applied, the force applied is going to be constant over that length. It may not be completely true, but it might be approximately true. So what we're seeing is that the force times the length, let's say in that first barrel, is just equal to, well, at first the bullet's not moving, right? So it's just going to be equal to 1/2 mv final squared of that bullet. And so if I'm trying to solve for, here's the speed of the bullet. V final is, what is it? Square root of 2FL over the mass of the bullet. Okay, cool. So if I know those things, if I know the force of the gases and the length of the barrel and the mass of the bullet, then I can calculate what the speed of the bullet coming out of the gun ought to be. Okay, so what I want to know is if I increase the length of the barrel to 4, this is, and again, this is kind of what the whole exercise is about. In physics, a lot of times what we do is we have an expression like this, and we're not terribly concerned with plugging in numbers to get an actual number for V, right? The important thing in physics, it turns out, is understanding the relationships between the length of the barrel and the speed. So that if I say, what if I increase the length by a factor of 4? Then what effect does that have on the speed of the bullet? Does the speed of the bullet go up by a factor of 4? I don't know, naively, maybe that makes perfect sense. But you need to figure it out, because a lot of things in nature are not just linear like that. So in physics, a lot of times we'll just say like, well, what happens if the length goes up by a factor of 4? By what factor does the velocity change? All right, so let's see. If L goes to 4L, then what have we got? V final is a square root of 2F times 4L over M. But instead of multiplying out to make that an 8 in the numerator, look, the square root of 4 is just 2, right? So if I bring that outside, that would just be 2 times 2FL over M. That's the same expression. And this thing was our original V. So this is 2. I want to call it V initial. What do I call it? V original? Anyway, you get the idea. So what happens is, because that L is inside the square root, if I make L 4 times bigger, then V goes up as the square root of L, so V becomes 2 times bigger. So if I make the barrel 4 times as long, then the speed of the bullet will double, right? It doesn't go up by factor 4, it goes up by factor 2. So this is the kind of thing that we do. What happens, and you can do some interesting things. What happens if I make the bullet 4 times heavier? What if I make it out of some metal that's, more dense? So if the bullet is 4 times heavier, then the square root of that becomes a half, so that it would go only half as fast, right? So this is a really common example of what we do in physics a lot, is to have an expression like this and then raise these things inside up and down by factors, and then just see what happens to that as a factor. And the more practice you get at doing this, the more you won't even have to write stuff down. You'll just know, oh, it goes as the square root of L. So if L goes up by factor 4, then V goes up by factor 2. This will just be thinking that you do instantly. Okay, so just a little example of things that'll be valuable to us as we go along.